Hello guys, I'm a teacher Limboka Sajuga Masame. Welcome to Limboka Physics. The question below states that a light ray enters the atmosphere of the Earth and descends vertically to the surface. A distance h equals to 100 km below. The index of refraction where the light enters the atmosphere is 1.00 and it increases linearly with the distance to have this value n, which is equal to 1.000293 at the Earth's surface. Part A. Over what time interval does the light traverse this path? Part B. By what percentage is the time interval larger than that required in the absence of the Earth's atmosphere? Consider the diagram below that will elaborate clearly the scenario of this question. We have a sun, and this is incident ray that traversing the vacuum, and here the incident ray gets refracted when it traversing the atmosphere to the Earth. Okay, the height of atmosphere is h. For the comparison purpose, we use the same h for the case of vacuum. Then time for atmosphere is t1 and time for vacuum is t2. This is the refractive index for vacuum, which we've given 1.00, and its speed of light in vacuum is, as you can see here. The refractive index for air we've given, and the velocity of light in air is unknown. From the Snell laws of refractions, as you can see here, is equal to constant. Then we make the subjective velocity of what? Of air, which is equal to that of refractive index of vacuum times velocity of light in vacuum divided by refractive index in air. Then we have this value in meter per second. Now, a time taken to traverse the atmosphere after refractions is equal to height of atmosphere divided by velocity of light in atmosphere. Then we have 333.4 microsecond. And in absence of atmosphere, we have time 2. And now we will divide the same h with a velocity of light in vacuum. Now we will have 3.3 microsecond. For the first case, we have asked to find the interval does it light traverse. The interval will take this in presence of atmosphere, which is T1, we minus with this in absence of atmosphere, which is T2, and which is equal to 0.1 microsecond. This is a interval. Then the percentage interval, we will take this interval, we divide with total time t, and then we will have 0.0149 percent. Therefore, the time interval larger by 0.0149% than that in absence of atmosphere. Okay. Thank you for watching. Please like, share, comment. Don't forget to subscribe to this YouTube channel for more videos like this one. Thank you.